we're going to go over the Pythagorean theorem converse in this video. So it's kind of proving not necessarily the opposite of Pythagorean theorem, but using it to determine what kind of triangle we're looking at. So remember, Pythagorean theorem says a squared plus b squared equals c squared, which is used in a right triangle to determine the two legs creating the right triangle. If we square and add them together, they will equal the same as the longest side, which is our hypotenuse squared. That's our c. So if we look at, we have three things that can come from that. So if c squared is less than a squared plus b squared, so we have the two legs squared, the sum of the two legs squared is less than the third side squared, then we have an acute triangle. If they are equal, so this is the Pythagorean theorem, then that means we have a right triangle. So that is the Pythagorean theorem. And then if we have c squared is greater than a squared plus b squared, then we have an obtuse triangle, so it's greater than. So we have these three pieces. So we can very quickly decide, do we have an acute triangle, meaning all angles are less than 90? Do we have a right triangle, meaning we have one 90-degree angle? Or do we have a obtuse triangle, which means we have one angle that's greater than 90? So let's go ahead and take a look at a couple examples. So the first types of examples they're going to give us are just three side lengths, and we're going to determine whether or not it's right. So it's either right, not right, or there's not enough information given. As long as they give you three sides, there's enough information given. So we're going to either choose right or not right. So we're going to take the three sides, and remember that C is the biggest side of the triangle. So 25 is my C. So I'm trying to determine, is C squared less than, greater than, or equal to a squared plus b squared? So I have 25 squared. Remember, 25 is my biggest side. And then the other two sides squared. So 7 squared and 24 squared. So 25 squared is 625. 7 squared is 49. And 24 squared is 576. So now I just want to add these two together to see how do they compare to 625. Well, they are 625 when I add them together, so this is equal. So this means that c squared equals a squared plus b squared, which makes it a right triangle. All right, so let's try one more of these. We have 7, 10, and 12. So again, I'm going to determine how does this relate. So I have 12 squared, 7 squared, and 10 squared. So 12 squared is 144, 7 squared is 49, and 10 squared is 100. So now when I add 49 and 100, I get 149. So now they're not equal. C squared is less than a squared plus b squared. So that means we have an acute triangle, which means it's not right. Okay. And the second type of problem they're going to give you is one like this, where there's still two questions here, but they just want you to determine acute, right, or obtuse instead of just right or not right. So now they're showing you the first part here. So they want you to compute the sum of the squares of the shorter side. So we have 11 squared and 12 squared. So remember, that's 121 for 11 squared, 144 for 12 squared. So now I'm going to add them together, and I get 265. Now I'm going to compute the square of the longest side. So 144 squared is 196. So now I want to ask the question between these two. Is it less than, greater than, or equal to? Well, 196 is less than 269. So since it's a less than, it means it's an acute triangle. We can kind of see that these all look like small angles. They all look like less than 90, but don't fully trust the diagram because sometimes they don't always draw it very accurate. So we're going to, again, compute the sums of the shorter side. So we have 5 squared plus 7 squared. So 5 squared is 25. 7 squared is 49. So if I add these together, I get 74. And now the longest side, well, that's 11. So 11 squared is 121. So now I'm going to ask, is 121 less than, greater than, or equal to 74? So it's definitely greater than 74. So that means I have an obtuse triangle. All right, so this was using the converse to the Pythagorean theorem to determine the type of triangle. I hope that helps, and I'll see you in the next video.